All right, so if I do the domain, I take the denominator, set it equal to 0, so that's an easy one. X plus 1, set that equal to 0, so x cannot equal -1. Okay, so my domain's pretty simple. -infinity to -1, -1 to infinity. Okay, now take -1. Okay, now if I want to take that so that I don't have to work twice as hard here, if I do my vertical asymptotes, I do the same thing, right? Set it equal to 0, solve, and I got x equal to 1 for a vertical asymptote, okay? But what do I have to do with this? I have to take it and plug it back in here, right? And it helps if I write down -1, okay? So when I do that, then what do I got? I've got 1 minus 4 minus 4, which is -3, plus 3, which is 0. So is this a vertical asymptote? It is not a vertical asymptote. When I take -1 and I plug it back in, I get 0. So this is not a vertical asymptote. So I have no vertical asymptotes on this particular graph. Okay, because you got to plug it back in, do its all little fancy thing, so it's not. Okay, so then I could do horizontal, right? I could take a look at the horizontal ones just really quick, right? So horizontal, top is bigger than the bottom because there's a 2, there's a 1. So do I have any horizontal? I don't have any horizontal because you got to have that memorized. So there's no horizontal asymptotes. All right, there probably is maybe could be possibly a slant depending on how that works, right? When the top is exactly one more than the bottom. I'm not going to do the long division and try to find it out because maybe there is, maybe there's not. Okay, so then, all right, go back to algebra 2. Let's take this function and see what happens. So I'm going to do it down here. Let's do x squared plus 4x plus 3 all over x plus 1. All right, let's treat that like we did in algebra 2. Can I factor the top? The top factors, right? It's a nice little trinomial. So if I factor the top, I'll have a what? An x and an x. And 3 and 1 is the only thing it could be because everything is pluses. So plus and plus. And then I've got the x minus 1 on the bottom. Okay, so then what do I have to do? I have to, well, it helps if I write down the right thing. X plus 1, x plus 1. All right, now can I cross it out? All right, so what's that tell me that's happening at x equals -1? I got a hole, right? I've got a hole because I crossed that out. That's that removable discontinuity. So from that, I can conclude that I have a hole at x equals -1. All right, now let's do one other thing to help you with the graph, okay? My original equation looks like this. X squared plus 4x plus 3 all over the x plus 1. But I've just taken this and I've simplified it down and I've said that this is equal to x plus 3 when x does not equal -1, okay, because there's a hole there. So this thing is equal to this thing, but only when x is not -1, because when x is -1, that bottom is a 0, right? These two things are equal, okay? Technically, because that's what we did, right? In algebra 2, we take it, we factor it, we cross it out, and then we say this is equal to that, all right? And the part that was left off in algebra 2 was this part. You just took this, you factored it, you crossed it out, and you said that was your answer. But that's not really your answer. That's your answer when x is not equal to 1. Okay, now if we're trying to sketch this, you have no freaking clue what this is. You don't know what this looks like. All right, but if I cover all that up, doesn't that look like y equals x plus 3? Doesn't that look like a straight line? All that is a straight line, right? So this has to be a straight line, but it's a straight line what? With a hole, because I crossed it out. So if I wanted to graph this, this one is way easier to graph than the other one because I know it's right there's my straight line. It has a y-intercept of 3 and it has a slope of 1. So when I go up 1 and to the right 1, I'm good. But when I get to -1, to the left 1, down 1, there has to be a hole. But then I can go to the left 1 and down 1. So it's a straight line with a hole in it. So this right here In a graphing calculator, it's just going to give you the entire straight line because the graphing calculator is not smart enough to put that hole right there. All right. But because you can factor this, cross it out, you can look, I don't have any vertical asymptotes. The domain fits because it says everything's in the domain except for -1. Well, if there's a hole there, it's not in there. I don't have vertical asymptotes. I don't have horizontal on this one, even though it's a rational function. Okay, but I do have a hole because of this hole crossing out action in a straight line. So you could have put this in the graphing calculator, except the only thing you're not going to see is you're not going to see that hole. Okay, you will not see that hole because the only way you're going to do that is to do it by hand, see where it's crossing out, seeing that it's not there. The only way you're going to see that it's not a vertical asymptote is to make sure that you plug it back in. It's not a vertical asymptote. If it's not a vertical asymptote, chances are then it will be a hole most of the time. Okay. All right. Are we good so far on all of that?